check your map and check on whether I know I checked. Only one person had logged in before I sent a message that I put. I haven't checked to see how many have checked out. My communication environment is well. You never get anything in the web from me. I mean, from me anywhere. So you gotta be friendly to Mwele as long as we are working together. We have been together this week. It's been a nice time. I will miss you. But, still have a couple of days. That's what routine means, when you do things step by step. So I made the test very simple to make life easy. If you didn't find it simple, then I'm sorry. So I started by letting you revise not letting you revise, but those who did assignment benefit from their efforts. Those who did assignment on tests. So I don't remember how the thing is drawn. But it has the structure, and a circuit symbol. And all I needed was, it is actually some stuff here. It can either be a P, this one can be a P, then NP, then you have these parts. So you have the gate, these are the same. Then you have the source, you have these what? Drain. And then you can draw it in this form. And by nomenclature, here, if it is like this, it means that holes will, is it holes or electrons? So I want you to remind me which arrow, where the arrow goes. I have a guide, so but I don't want to go with the guide. So you could either draw this and put the arrow, which arrow goes by what? By electron flow or the whole flow? From source to? Don't trust nobody. I will jump that. But I needed to give you a half here and a half here. You could draw this or draw the other one, which is NPN, and then the arrow. So this is source, drain. Only one person did this. And I thank myself for having stuck on being on his case while he's concentrating in class. So my efforts paid off. I won't tell you who that person is, but he knows himself. The time is gone. It is not going to help you. We are left with 2 days. 2 days, and then I have to remind you that exam, we shall have an outing on the weekend, on Saturday. May 17, 08 to 11 hours. I hope I will not grab this one today. I want to chop Compare the two. The comparison is that we got the grammar. Why is everyone using the left? It started with some guy I was with, and he always used the left. I said, "What's wrong? I give you things, you use the left." Until when I kept refusing, changed a little bit. Now all of you are doing that. Don't they teach you manners these days? And I don't know anyone here who uses the left, right? I haven't seen any. That one can only be the one to have an excuse that is what is, but he used the right when he was receiving his paper. Others, you put your thing. If it was a food, I wouldn't give it. How? It shows that you are not, it's not, you don't have to put two, but at least put the right one. The next one is about the differences. Comparing, there is less power for FETs, high power for BJTs driven by voltage. So here or there were like 5 of them. I only needed two pairs. So that one was taking 2 marks. You want real answers or? Okay, if you want real answers, no problem. Let me look for your answers. I have no time to put answers in my head. Let me get them. They are on a guide, so let me get the guide so that you don't crucify me. I'm doing this so that when the exam comes, it's the last exam. My exam, I will campaign for it to be fast or middle, because last you always have issues. By the time you reach the last day, you have flu, you are disappointed, you have many problems. So I would wish it came a little bit nearer or in the middle. But the one the next year, no, next semester, those who would do instrumentation, I think it is the first paper. So I have seen both, when it is the first paper and when it is the last one. Just be patient, I'm just getting it from the Google Drive and then open it so that you get the answers since you are interested in the answers. But that number one, I wanted to reward those who do assignments. Because when I said assignment and said handing, and then I didn't bother whether you had handed in or not, you were like, it was wasting your time. So I wanted to give, and I'm glad those who did spend time. Anyone formed any addition problem or jumping? I could have jumped. I could have jumped some stuff. I mean. Could have jumped some but there's one thing, as this opens fully, there's one thing I don't like. I gave you free paper and then you write everything. don't remember, if you don't know, don't just fill the paper because you want to do something on paper. The reason I'm a happy person, I will end an exam or a test, I do what I know. That's it. So you will get a half for this, and then when you draw this other one, I'm just drawing it huge so that you get there. So this is the, so still we have the holes being responsible for the production. This is the drain, this is the source, and you will get them half. Or you could have drawn the other way, the other version of PNP, and then you have the drain, the gate, and then you have the source, and then now the arrow. I'm sorry, this arrow comes from here. It's almost. So then we have this one goes in at the gate, source, drain. So since B, this was F, this is the circuit symbol. And then the comparisons are that we have FETs here and BJTs here. These are unipolar. These are bipolar. 2. They have high impedance. So I'm not going to say they have those. I'm just going to show the comparison. So these ones have low impedance. And then they use a lot of power. So these ones use low power, so low power dispersion. And then the other ones, of course, would be the opposite. So high power dispersion. Then we have low noise. These ones will have high noise. Then these are voltage control. These are current control. Mostly used in digital electronics. Would we say electronics or circuit? The most appropriate one is circuit. And then here, mostly using analog. And I remember the assignment was to draw the comparison with the BJTs. So I have put it right. Feedback. Feedback is when you put all or part of the output or the input. This thing is in the notes, so I am not going to write everything here. This one I only needed any of the two. Any of these two, then you will get 2 marks. Whether you put all of them, I would choose any two and give you that. And it says seen. I have seen this one, I've seen this one, I've seen this one. Like I said, learn how to read the question and answer it the way it should be. So what is feedback? When we put all of the output into the back in input, 1 mark, differentiate between positive and negative feedback. I only needed you to say positive feedback. Is it A prime being the same as A over 1 minus KA? And then negative feedback is positive. So A equaling to A over 1 minus K plus. I'll give you a half. I didn't care whether you defined what A prime is, but you needed to do that. Where A prime is the closed loop, A is the open loop, and K is the feedback factor. I'm trying to race with time. I wanted you to get feedback of your test, but I also want to finish the stuff. And the time is not our best ally. Differentiate between, so draw a circuit symbol for an operation amplifier. Some people just want, I don't know, I just needed you to do this. Circuit symbol, whether left, I didn't even bother to say well labeled. If you want, you can say this is inverting, this is non-inverting, or you can draw them reverse way. That's it. And I give you your eye. Some people even put some resistances around. I felt bad. All I did was those who put a feedback resistor here, I still just did like this and singled out this and gave a half. Just as a parent. It's tiresome. It's tiresome to be a teacher. And we say that we have infinite gain, and you didn't need to explain to me this then causes VPN equaling to VN. No, just give me the damn assumptions. Infinite gain, infinite input impedance, and 0 output impedance. That's it. Differentiate between digital circuits and analog circuits. Digital circuits have continuous continuous values, and then digital circuits have discrete. So I just needed to see under digital, I needed to see a word discrete, and under analog, I needed to see data is represented by continuous values, and some of you don't know how to write continuous. Some of you follow your teachers who were speaking it in Uganda as continuous. So some people were writing continuous. This is not continuous. There is a U here for continuous. variables. Frederick, come for your work. I don't want to go with it. So that you identify the problems as I do this. So you use any language you can use, and I will give you a half when I see the word continuous and discrete. Half. That one point that I wanted you to tell me about how the digital circuits age on the analog circuits was that there is reduced noise, and this one, many of you grabbed it interference, and this was because of regeneration, that this can be regenerated. The wording is nicely put in the notes. That if you want, I can put this guide online. So the effects of noise and interference are much reduced, 1 mark. And then the main reason is that digital pulses or signals can be regenerated and thus restored at any time you want. The other ones were definitions, and I was happy in that time on that part of the note because you did it well or not. I was happy that I over-explained about rise time and fall time and the delay time and the pulse width. And at least a number of you who attend my lectures passed that. Rise time is time taken for the pulse to rise from 10%. Some of you want to act so smart, so they just put it or it one. If I'm not in the mood, I may think you are writing. I may think you are writing something which is not normal, and by the time I remember that 10% is 0.1, then you find to 9%, and the key word is of the peak value. So most of you are fall time, time taken for the pulse to fall from 9% to 10% of the peak value. Pulse width, is this pulse width? Is the time taken for which the amplitude is greater than 50% of the peak value. Time taken for which the amplitude is 50% of the peak. It wasn't necessary really to draw that diagram in full. I just saw it, so I say the scene. It was not necessary. This is my advice. Only do those things when you have budgeted your time and you want to show me that you know. But does it help? Does it help you to show me that you know? I have a guide. Whatever you are putting, I know. I'm only making sure that you do it in the right time and excel. I wanted you to excel in this test. If you didn't excel, it's not a good idea. The other thing is propagation delay time. All of you passed it except one person who refused. This is the time it takes. This is experiment E7. This is the time it takes for a change in the input signal. Avoid being restricted. Signal could be current, could be voltage, could be power. So just play safe. So propagation delay time is the time taken. These definitions are in the notes. It's the same way they are in the guide. So this is the time it takes for a change in the input signal to produce a change in the output signal. What is a logic gate? About 5 people beat around the bush. A gate there is that word for being a digital circuit. It's a basic digital circuit, and some people are stopping there. A logic gate is a basic logic circuit, and then they put full stop, and they want me to back. So a logic gate is the most digital device which has one or more inputs and a single output. Those people who were stopping there, was giving them a mark. If your mark is like this, or just like this, I gave it to you with a lot of pain. There is no tick there. There is a mark, but there is no tick. You know, I just gave it to you because I don't want problems. Otherwise, I was not going to give it to you. I was just going to write there sing. It's just like this. If it is a half, I was giving like this. If it is full, I was giving. But if I just wrote there like this, I wouldn't have given you if I had. So it's with a single output, depending that is a function of the current inputs. It's not current. It's not the current charge per unit time. It's present. The current here is equivalent to present. The ones you have just put in the inputs. Given the 3, some of you listed them: OR gate, AND gate, and because Max awarding was very tricky, I had to just say I've seen these ones, but I will give you the mark when you start putting. The OR gate is a fish, it's like a fish head. There is a sharp part here. So you don't just do this and then do like this. Makes sense. This is not O. And then, so this is the O, and I will give you a half, and then the A, B, Y, 0, 0, 0, 1, 1, 0. There are people who really want to cause problems. There are those who just put 0, 0, 1, 0, 0, no, 1, 1, 0, 1. One I had even cancelled this. Then when I looked closely, then I had to. Why cause problems? When those of you who are doing education, when you graduate, okay, and you are now a teacher, you can change things. You can do things in the way you want. But here, why do you make my life difficult? I'm also doing something else as I mark you. Probably I'm watching the news, and as I'm marking, I'm like, this one, how can you fail? We check, the combinations are okay, they are okay at input and output, but they are disorganized. So this one also I was giving you a half. I felt bad that you write all that stuff, I give you a half. Then we have this and then you have the okay. also very happy here, except the few of the one who had not filled in this one, and I'm sorry when I said stop. When I said stop, he was still continuing, and I said please stop, and he left them. But it's not my fault. Okay? But I was happy that my efforts in the lab paid off. But this is where I got perturbed. How can you draw that this is a not gate? You deserve, if I was still teaching, when I used to cane students, I would have caned you like 6. I used to cane students at one point, but now I cannot cane anyone. That this is a not gate. It is. But not in words. Not in words. If you did this, you know I virtually slapped you in the chin, eh? I gave you a big slap. You may feel it one day. You don't know. Those of you who are doing education, you don't know. It's not that I'm mocking you or whatever. There are things you fail, and actually they were tricky. But this is something even if you have, and I will find out whether those who did that had done that experiment. I would make sure that I explain and I show how even a NOT gate was, exchanged with an AND gate with short-circuited inputs. And because we wanted to buy only NAND gates so that we use them as NOTs. But you can't do a diagram. And then you're confident to say this is a NAND gate. So then here you have A, Y, so you have A, you have Y, and then if it's 0, it's 1, it's 1 it is. And then I give you a half. These were 3 marks, I feel. These ones here were very 3 marks. Because I did this in the lab, I did them here with diodes, I drew them many times. It's beautiful. I don't know. I don't know what makes you happy, but for me, when I come and I teach, I feel happy. When I was a student, when I would do a test and it comes out nice, I would feel like, yes. So I don't know what makes you tick when you are here. Give the 3 main types of gates. Write down the De Morgan's. So some guy is not here today. He wrote this one, De Morgan, okay? And he wanted to show me that x1, x2, xm equals to x1 plus x2 or xm. Hello. It's okay, but why do you cause problems? Why? When there is that simple one that I gave, and then went on and said this one. From today onward, at least in my course, watch for the words listen, state, write down. they need what they need. Listen, state, write down. If I say explain, explain, but also I think you will always find explain briefly, because you can't do explanations. I don't have time to read stuff. Briefly explain or explain briefly, and then the other one will be A or B, because then there is one who forgot. Forgot. So when he forgot, he wrote this one in reverse. Say this. And he thought he had stated both of them. I see. I see. So put these two. That is that. You have forgotten this one. I see. So this is the same one. They are the same. Don't do that. Okay, so that was the test. It was just to make sure that those who attend my lectures benefit their attendance. It was almost, apart from the part of the fates, the rest really, if you were attending Goris regularly, you didn't have any issues. So if you have any issues with the marks, after here you can come and correct if I misadded or cancelled what you believe is right. Then this was very smart. Oh, this, I think just interchanged them and thought I would just do this, and they were half-half. Oh, there's one left, isn't it? They were half-half. The last one was to give the circuit, the draw logic circuit for, this is D2 of A and B or C being equal to whatever. So this is A, you put it so it's and here of A after it has been so it is B or C here. And this, so then it will be going for B. Yes, I corrected this, it was BC in the test. I corrected it in the test. You drew another circuit of two hands with an O. Just so. Because not bad. So you got a half here for this O and a half here for this. That's it. And it was marked out of 20. So if you got below 10, and this is our last test. You have to work for exam, you have to work for 60 and above. Any query, any complaint? If you want a video, we can see. I can give you a video test. For those who go below 10 and think they need a chance. chance, I can give a remedial test on a day before Friday, and then you work out, but you never know what you are going for. It's a remedial, so when I say remedial, it can attract others, so I make sure it is a remedial. You really come when you come in for, you know, when the return leg, when Madrid has been here, that kind of thing. So we now go to the last part of the course, and I'm not worried. Even if we don't finish, we have already finished the course. True or false? You have seen it all. Now you can, with the basics you have, you can read or watch a movie or electronic stuff and work on your gadget. And so this is just the last part of the course. So we look at the video to analog. We have learned about analog signals. We have learned about digital signals. We know what they are. We know how different they are. We know a little bit of advantages of what they are. And unknowingly or knowingly, I told you that every day you use conversion and you don't care how it works. So if I am on Wi-Fi and I'm on YouTube, I'm having digital signals from the Wi-Fi to my phone, and they are in a digital form. And so the phone using the app, which app actually takes on a 1010, you don't see nothing, you don't know how it is changing music or video to be played, and then when you plug in or just connect by Bluetooth, you start enjoying the music, which is analog, because it is just coming out of the speakers of the phone or through the earbuds. The sound is just coming out, pushing the air pushing your eardrum, and then you are shaking the head. What was digital here, that you were just sliding and tapping to get the song, eventually now is continuous. It's a continuous sound signal exerting pressure, because when we talk of the analog some of the analog variables, now for example temperature, you can have a temperature up on the phone, and then you are there, it tells you how hot this place is. You have volume, in terms of if it is a liquid, you have the pressure, you have etc. and other things. So I'm bringing this pressure here because that's what the sound will be causing the air to cause, to make pressure on your eardrum. And then you start, I meet people with these big headphones. Even when they are, how do you cross a road with the headphones? Common sense. You see somebody, you may reach in the middle and the music is nice and you want fast shaking, and then some stupid drunk driver just runs over you and you are like,
But you can go to heaven, I think. You may go to heaven if we are busy listening to nice music. Say, Makura, come for your work. So that you don't... anyone else here that has not got their work, who came there? So this is what we're going to learn. It's not, I mean, everything is just electronic. We use resistances and operational amplifiers to do the conversion. But I want you to understand what it means by, if it is a digital signal, how are we looking at it as analog? If you are in the lab and you are typing my assignment, you are just busy tapping, and that tapping, your input is analog. You are tapping this, tapping that, and then all of a sudden everything appears on the screen, and now you can play around with it. You can bold, you can, indent, you can expand, you can change color, you can, and if it is new, so I now am here busy doing all the gestures I can, speaking, my camera is picking up my voice and is encoding all the stuff in something that is being stored on a small SD card. And it is now, it will be digital. When I reach the office, I just plug it into the PC, just plug that cable in the PC, go to YouTube, upload. And then in a few minutes or in a few hours, the video is online on where. Here, what was this Kanua's voice now can be heard by people in America, even in heaven. Some who had interest in physics. Fortunately, they told me that in heaven we don't know each other. So there is nothing like when we meet there, you say, now you were always this fun and now you are accepted. You won't know me. You won't even know your parents. It's just praise. Everybody is the same. No hunger, nothing. I don't say anything. So let's see the advantages of digital processing. The issue is, why are we doing this conversion? Why are we converting from analog to digital? Why are we converting from digital to analog? You convert, you have to do analog stuff to type, even on your phone. You have to type your stuff there, it goes into your phone, and then it becomes digital. You send it on X, you send it as a message on WhatsApp, and then nowadays WhatsApp, you can even now use analog. You say in a voice note, then the other guy just opens the voice note and changes it into word text. So you read text when actually it was a voice note, is transcribed to the text. So then you can't watch, you cannot read your stuff on the phone if it doesn't become analog to be read. So when you are reading stuff on the phone, what was sent as a PDF via the Wi-Fi, it comes here, it has to be analog on the screen. When I was busy looking at the I hope it has not disappeared, the marking guide. When I was looking at the marking guide, I am able to look at the marking guide now because it is I'm using an analog screen. I'm seeing it. I can scroll through, look through and see, because it has been converted into, it has to be converted into analog from what was digital for me to be able to see. So that's why it is ADC, DAC. So we need to know the two. But why the hassle? We need to know the advantages of digital processing. So these advantages are, we have accuracy. When you have typed work, then the stuff shows up. Now you can bold, italicize, change the grammar. If there's a grammatic problem, spelling, etc. So you can maintain accuracy. Then flexibility. Once you have your text, I'm just using an example which everyone of us is able to access, a computer and or a phone. You can copy, paste at the beginning. If there are things which are the same, you can change a word and put it the other side. These days when you are typing and the word comes up, you just slide, the whole word comes up, so there is flexibility. And then you can, in the videos I told you about, these ones on the road, I have a song which I wrote on and has no copyright, but if I have a video of 2 hours, the song is about 4 minutes. So I have to choose a part of it to repeat. So I make it repetitive and add it on. So you can do repeatability. If you have a nice song and there is that chorus, it's called chorus. How is it called chorus called in English? Oh, it is the same as chorus. Like that repeating part that you love. But also you can, if you have a diagram here and you wanted to use the same diagram for explaining some other part, you just copy paste. So that is the repeatability. And then you have nowadays quantum computing or quantum computers which do amazing complex operations. So we have ability to perform complex operations. So next semester will be in third year.
Yes.
So you'll do computer programming in physics, and then you'll understand that now you can do amazing stuff. But even if it is not that far, nowadays, if you want, as long as you know an appropriate app to download, you can film a movie, edit it here, even upload it here on phone without needing anything. But of course, there has been some computers now which are using quantum computing to make sure that they can do complex things. So, in short, or in a schematic, we have an analog input. Could be a mouse, it could be a keyboard, could be a microphone, could be anything of the sort. And then we can convert this one from analog to digital. So we have ADC. So the keyboard changes the tapping, the pressure you press, the pressure you are exerting on the keyboard. I used to, when students, those times when there were no many smartphones, they would come to my office to log in or open an account. So I'm like, okay, you type your password. I don't need to know your password, like we are opening an account, and then it looks like. Yes, my keyboard was verified, it was in Norwegian, but still you wouldn't have to look for things like that. So like how chicken pigs feed. Then I used to laugh at them. I used to say, now you go around and say, we are .com guys. Now in the keyboard you are looking for stuff. But this pressure that you are putting is being converted into a digital signal. And then it is being now processed by a computer. And so here we have a computer. And this computer also has to have something that is to show us what is going on. Imagine if you were typing without a monitor. How would it be? You are like, then you say, okay, it is okay. So whatever you are typing has to now become visible somehow. And it could be just straight away as a digital output, or you first change it into back to the analog DAC, digital. You use a digital to analog converter, and then you actually get an analog output. So if you had a mic, and your mic, is it called miming or karaoke? Let me see whether I can sing something. If I was to sing for food, I would die of hunger. So you sing, after singing, the analog to digital converts it, it goes in the PC, and then you get an amplified signal out here in a speaker. The speaker is an analog output. So, but before it comes out of the speaker, there should be a digital to analog converter to make sure that electrical signal that you had in the circuits becomes sound that we can hear. Simple, an example is the public address system. So I will just give you, okay, in this course we shall just make sure we know about conversion, but in the next course, those who will choose to do electronics and instrumentation, we shall do what we call sensors and transducers. We shall understand when we use a microphone as a transducer, and then look at how this microphone actually changes the physical signal into an electrical signal, and how we can manipulate it. Either you have seen an encoder, you have heard of the decoder. All of you know a decoder now. All our TVs now need a decoder, either external or internal. The Nyash TVs don't have an internal decoder, so you have to get an external decoder. But the flat screens, all of them, most of them have a DTV. So when you choose DTV, it uses an inbuilt decoder. But the Nyash TV is all done. Okay, sorry, the ones which have a CRT, these ones which were like this. These are the ones I'm talking about. The ones I'm calling the Nyash TVs. With the CRT cathode ray tube inside. So let's start on the DAC. Digital analog converter. So the methods we use are, we use a weighted resistor method. So we can talk, for example, a 4-bit, an example of a 4-bit digital analog converter. So we have an assembly of resistances, each of them having a switch to engage, to put them in or out of the circuit. If you allow me to draw this very fast. And there are 4 bits. It's a 4-bit, so we have 4 resistances. And then all these are fed in an operation amplifier.
this is the feedback resistor, feedback current, and then this is current I1. So R, then 2R, 4R, 8R. That's why we call them weighted. This is I1, I2, I3, I4. This is the reference voltage. And then we have the switches S3, S2, S1, S0, with this being the most significant bit. And of course, this way becomes the least significant bit. How does it work? If each of these switches, so if it is this one, which is only have only one bit, this, if the two of them, 2 bits, 3 bits, 4 bits. And so, if we follow the assumptions of the operational amplifier, we can't have everything going here. So I1 plus I2 plus I4 plus IF equals to 0. That's why we did the operational amplifiers, so that we could use them here in our stuff. So if all switches are closed, then we have I naught. I want to be sure that I labeled something well. This we follow. Sorry, we follow these. This one. This is 2. This is 1. This is not. Sorry about that. I4 switches are so I naught plus I1 plus I2 plus I3 plus IF equals to, I don't have to explain this, that was the, or if we consider each of them, we would have I naught is 8R and the resistance is 8R. So we would have Vref, is the only one on, it would be Vref over 8R to get I naught. So, and of course we only have Vref, so all of them is Vref over 8R plus Vref over 4R plus Vref over 2R plus Vref over R. Now we go to this other side, is V out over RF equals to 0. And V out would be the same as minus RF Vref in 1 over 8R plus 1 over 4R plus 1 over 2R plus 1 over R. And we would be able to get a value of the output voltage, which would be, so in general, a switch, any switch SN can be represented by a bit, can be represented by a bit, Bn, which is 0 or 1. If it is off, it is a 0. If it is on, it is to the power 2 to the power 3 minus I r, where I can be 0, where I is equal to 0, 1, up to 3. This mathematics people, this means what? 0, 1, 2, 3.
Steps.
V out then, if you are all able to see here, would be the same as minus RF over 2 to the power 3R V ref summation I equal to 0 up to 3. Then we have 2 to the power I. Then we have the bits PHY. Now for n bits, these were just 4 bits. For n bits, these 3 is because of the form. V out would be the same as minus RF over 2 to the power n minus 1. That's why we had a 4 minus 1 giving us a 3. Then V ref, and then we have summation I equal to 0 up to n minus 1. Then we have the 2 to the power the so we will be able to make about, you have issues here? Mathematics is 0 in steps of 1 up to 3. That's what that Note that the maximum value of the output would be the same as minus RF over 2 to the n minus 1 R V ref into 1 plus 2 plus 2 to the power 2 plus 2 to the power n minus 1. And then this would be the same as minus 2 RF over R V ref in 1 minus 1 over 2 to the power n. So V out minimum. The reason I'm talking about minimum and maximum, when we are converting and we want to have what we call the full scale range, we need to know the minimum and the maximum so that we get the range here in between.
So the V out minimum is the same as the full scale range times 1 minus 1 over 2 to the power n. And then the V out will be the same as full scale range times 1 over 2 to the power n summation I equal to 0 up to n minus 1 2 to the power I bi. Full scale range so full scale range is equal to minus 2 RF over R VF, the reference voltage for full scale range. When we make a signal, when we convert a signal into a digital signal, we must be concerned about resolution. How nice does it look? So resolution, these are terminologies you find in conversion. Resolution is the smallest change equals to the smallest change of the analog voltage that can be represented by a digital watt. This corresponds to the watt zero zero 01. In digital words, 010. If you have 0101010001, so you have a representation of zeros and ones giving you either a number or a word. So when I say digital word, I mean a collection of ones and zeros. Represent message, general message. This is the symbolic stuff that I said about of having a music on the phone which is digital and you are listening it and you are even happy. Your brains are very nice to enjoy. Hence, the delta V will be the same as the full scale range over the 2 to the power n, or the delta V over full scale range should be equal to the 1 over 2 to the power n. This is the difference between the minimum voltage and the maximum, which should give you the full scale range over the 2 to the power n. So this method, what do you think is its problem? What is its disadvantage when you look at it? You're having a bunch of these resistances, each of them with a switch, and each of them is representing a bit. So if you wanted 8, these were just 4 bits with 4 resistances, weighted resistors, R, 2R, 4R, 8R. So if you wanted a 16-bit, you want to make a 16-bit converter, how does it look like? You have now how many resistances?
16.
So disadvantage of the weighted resistor, method. The wide range of resistance, the wide range of resistors are to 2n minus 1 R. 4-bit was up to 2 to the power 4 minus 1 R, which was 8R, which will be 2 2. So this big range of these many with matched, what do resistances come with? With matched temperature coefficients. Matched temperature coefficients, because they heat up, and the resistances also age. Okay, they burn up. They may not burn up completely, but that burning up, heating up, and cooling down, heating up and cooling, aging properties or effects. Difficult to manufacture. Those who have done D14, you see how you struggle just to get a few resistances to do a few maneuvers. For T is for DAC. So imagine you are making a 16-bit and a 2-bit. Then you have to get a range of these resistances. You have to make sure they have matched temperature coefficients. They have the aging properties. So maybe you forget about defects. And to make sure they have nice properties, it is hard to manufacture such a stuff for such a... So what do? The other one now is almost the same with a different connection. But we shall see how nice or how difficult it gets. I just want to check whether we shall be able to finish DAC today, then tomorrow we do ADC, and Thursday we just come to say bye-bye to each other.
Excuse me.
Yes.
Did you intend not to give us attendance?
Huh?
Attendance.
Attendance. I didn't intend. I already have it prepared, but because I started with see, when you program your head, thank you very much. When you program your head to doing such things at the beginning, so my head was like I had done it before. I think there's a time I forgot it. Only once. But that day all of you were there because you were going to do a test of corner. So I assume all of you were there. Just an assumption. So you feel it very fast since it is coming in. But what do you have after this lecture? Test. No, I'm not asking that I call you. I am not interested in calling you. I'm in time. I'm doing well. I have already marked your test. I didn't have Easter. Me, I was marking. Friday I was sleeping. Saturday I was sleeping. Easter I was marking. I finished. Uploaded your marks. I don't believe Jesus was killed. So why would I waste my time? But because it is a holiday, so I decided to work from home. And then yesterday, and actually I think even Easter I relaxed. Friday relaxed, Saturday relaxed, Sunday, when Easter subsided, like when you know that people have finished lunch and whatever, then I made the guide, added marks. The guide was ready, but marks were not there. Then marked a couple of people, and then yesterday I finished everything. And for you, we are enjoying. Yes, we are covered. There are people who are enjoying. For them, they were enjoying. But on 17th, I will also be enjoying. I'll be moving around like this. I'll be moving around like this. Around the room. I don't know which room we shall use. Probably we shall use the same room because the numbers, the four numbers are not so bad. And I don't want to have many rooms with many people. So second one, we look at the R2 ladder method. We still have a chance to use only one type of resistor, but make sure that they are, whether we connect them in series or whatever. But here you have to make sure that they are in this range. So if this is 1,000, 200 would be 2,000. So you cannot say you are going to connect them in series to add them up. How about if they become 8R? You have 8 resistances in series, so they have to be that value manufactured. That's why the manufacturing is a problem. E.g., we take a case of a 4-bit digital to analog converter. So we're going to have a VREF, if you could let me draw, so that when I mess up, and then we have 3 resistances here, and then the other resistances down here. then make these switches either go here, and this other one will go straight to our operation amplifier, or so we can have this or here, and then we also let this one go to the operation amplifier. So this one comes here, this one goes here. However, I'm putting these dots so that we show which one is connected where. And then this one goes here, this one goes here, this one goes here, this one goes. Are those first years or third years? First years. I love it when I have not met students. When they see me, they are like, this fair. You even find them on the entrance and you have first them like this, then they allow you to enter. Now when I start teaching them, when I start teaching you and you meet me, now when you see me, you don't want me to reach nearer. Because now you know my character. I used to enjoy it when I would meet you in your second semester, because I would tell you when you are still a fresher. But now I'm meeting you in second year when you are already bent. You know that bent stick? That we say that a stick is bent when it is still fresh. When it dries up, when you try to bend it to straighten it up, it just works. So we have S3, S2, S1, S0. This one, this side of the switch is bit 0. This is bit 1, bit 0, bit 1, bit 0, bit 1, bit 0, bit 1. And then we have this other part with the RIF, the feedback resistor, giving us the V out. And this whole line here, since it is bit 0, so it is grounded. And then the other levels are, we start from I3, I2, I1, and I0 or I0. And I guess those are the most levels in this diagram. So if the switch is here, it is off. It is off because you are connecting it to the ground, so that's why we have it as bit 0. You can see how people came up with such things to make electronic stuff. And then for us, we are eating potatoes and bananas. And we walk around happy, smiling. Even when you are at the university, you go back, those who went for Easter, they are like, hey, our son, how is Makerere? Our daughter, how is Makerere? Yeah, we are there. We are enjoying. I don't know. Me, I didn't get that chance. When I would go to the village, I'm home, so I don't know those things of how people ask you how things are. But at least when I come to class, I try as much as possible to make you understand. I try to explain what I know. So I don't know, these people who designed all these things, they are not born from heaven. They are human beings like us. And you can say, but who you, what have you done? I cannot teach you and then start thinking. Now already I'm thinking of how I will teach electronics and instrumentation if you choose to do it as an elective. So I can now start thinking of either creating a converter. But someone thought if we put these resistances together in this form and we put these switches, if the switch flips here, you have a 0 bit, and eventually came up with a formula to make sure that we get. So using the same analogy of the other conversion, we say that suppose all the switches are on. Suppose all the switches are on. Meaning what? If they are on 1, if all of them are on 1, since it is a two-way switch, then the equivalent circuit, is we have Vref, then we have a bunch of these other three. And then we have the other ones going down. We have these two other here. Two other here. Two other here. And then there is an arrow here. And if you look closely, we shall have I am seeing this is 1, 2, 3, 4, 5. 1, 2, 3, 4. There was supposed to be 5. The one's going down, so I don't know which one I missed. There is one on the diagram which I missed, so I don't know how we are going to fit it. It goes straight to the ground. Sorry. When I drew, I was comfortable. So the other one goes straight to the ground. Straight to the ground. Maybe I put the ground here. This is where I missed it. When I explained that this whole part system, so it goes to the ground, but also there is this one. It's also 2R, and then there is this one here for the switch. The switch to switch. So we can still do this and do this. Will you be able to put it there? Yes. If you can fit it there, I'll be happy. Then we have 0, 1. The current is here, we have I out here. This is connected to the ground. We don't expect any current to go through there. Because this, when you put here, there is no current going through. But when you put it here, you have current flowing through. So this other one doesn't have a current. So we have this, and then this and make sure you draw them nicely. Don't draw them like the other time when you are doing like this. I'm sure now you are saying it. I'm sure nowadays you are drawing things nicely. At least in the lab you are, and you pass, isn't it? Where you are going, the smell. Not very many people, maybe because it's for a long reason. Not many people's names are remembered by their teachers. So if I say your name, you should be happy. Forever and ever, as long as that lecture is, that video is on, then your name will be heard. Don't sue me. I have a lawyer. Some of you say, I have my rights. How do you feel? Like those who are filming in tests. How do you feel me? I have a lawyer. Once you are in my test, you are my property. But also, you have ever seen my class videos anywhere, not on YouTube, like of you students in a test? Yes, you are on YouTube, but it is just for the class. It's not open to everyone. But the day I will produce them, those who do like this, I used to have tests here, and then someone is constantly like this. It's like he's left dreaming to look at someone's work. And sometimes I would see them there, then I point the camera, then I start looking the way. So they are like, he's not seeing. But when the camera is zoomed, I'm seeing properly. Okay, so you can now see why it is called a ladder. If you were to look at it closely. Then we have I3, I2, I1, I0, and then we have the current here from the reference, which is giving back to all this. So I want to start from here. I don't want to write any other statement. I want to start from here when you have picked through online to see what it's all about, so that we finish this tomorrow. And then, although it was just a little bit of it here, and since you are saying that you have no lecture, the 8 minutes can make me finish this, so that we start on ABC, but not in a rush. Not in a rush. I'm almost finished. It feels like magic, isn't it? How we have moved together up to the end. No dodging, no problems. I don't have problems. But even if I have them, they are mine. How far is the attendance? Because has everyone written? No. How many have not? Okay, so you make me on you to make sure you finish. There's another list here. Agaba, what do you think? I'm a human being. I marked your work, finished it, I also get tired, so I want peace. After the lightning accident, I decided to live my life. No one can scare me. I know how it feels to die. So no one's, I'm invisible. Don't scare me. And I don't rush my life. And I'm in my bonus. I'm 12th year. I mean, my 12th year as a bonus. God gave me, said, you go and have fun. Today is not your day. That's why I'm generous. So we shall start from here, finish tomorrow. Well, not finish, but complete. Then Thursday, we shall see what we plan to study and whether we have actually studied it. Then the group of tomorrow, make sure you come ready to, I don't want to quarrel on the last day. Come so that we do the practical. I'm sorry, those who will miss the last Wednesday, the 30th, April 30th practical, we shall never do it. Because Jesus decided to die. And we couldn't use the Monday, and the other Monday, we were busy doing it. It is not my fault. But at least the practicals you have done, so far so good. They were able to give you an idea of what theory you were covering. Okay, enough of talking. But I will miss you. I will miss you for when you'll be gone. My Tuesdays, Wednesdays, and Thursdays will never be the same. Everyone got their answer sheet? If you have issues, if the marks are not the ones on the way, or I jumped some stuff, or I discounted, you can come and then we rectify. Otherwise, I see you tomorrow at 11.